All right. But with lucky 7, what happens in the integration by parts formula? Let's write it up above really quickly so we have it to refer to. What is the lucky 7 formula? The integral of who? U dv is equal to uv minus, good, ultraviolet voodoo, right? The integral of u dv is equal to uv minus the integral of v d voodoo. I don't know how to get the minus in there. I have no idea. That's all right. The uv minus the integral of v du. What changes in the new integral that you will still have to solve? What changes? U becomes what? U becomes du, right? U becomes du, aka u gets derived, and dv becomes integrated. So in the rule, right? We say either choose u to make it simpler when derived, or choose dv to include as much as possible, be able to be integrated, or a combination of the two. So what's one way that we could think of this? Would choosing e to the x squared seem to be expedient? Because what happens when you derive it? It actually gets worse, doesn't it? It's e to the u times u prime. Oh, great, it's worse. Well, that doesn't seem to be helpful. So then, okay, what if we put e to the u over here? Well, wait, we can't integrate unless we the dx. But so what else would we need? Right? Because don't you need a u sub to work out? Well, you can always put that in. Does that make sense? Okay. So we need the x, the constants we'll deal with. I mean, we haven't done this yet. Okay, so if we put that there, then question, what's left over for you? All we've thought about so far is u. Really. We said, hey, should it be e to the? It's not simpler. So then we say, okay, well then e to the goes down here. Is it simpler? So there's no choice for u that makes it simpler when derived. Well, okay, then let's stop thinking about u and let's think about dv. Riley, go ahead. Dx. Because if you don't, you technically can't integrate. And one of the big things they kept saying on the Saturday workshop, both the head of College Board over calculus and the chief reader who's over the entire grading of the AP exam, which is actually a position that can only be held for 3 or 4 years, and then you have to switch out. Interesting. Small fact. He has 1 more year, I think. No, it's the completion of this year that he's done. He gets through this summer. And someone that he taught calculus to in high school is taking his place. Interesting. Anyway, pretty cool. Now we're going to look at dv. We just had this in dv, right? Does this get simpler when integrated? Yes, but it still has an e to the, right? And isn't it still going to have a mess when you derive that other blah? Well, it's going to have an e to the times a big old mess. Does that make sense? So then what if we say, okay, what's the hardest possible thing that I can put in an integral and have it be integrated? But the bottom, it's not possible to integrate right now unless you have a what? U du. Don't I need an x up here? And yesterday I was like, can't we add in more x's and do some integration on crack stuff? Here's the dilemma. Can I show you from those who have gone before you and have suffered over this problem for multiple minutes? We tried this guy. Do you see how nasty his derivative is? And with that derivative, do you see how nasty the integral will become if you put him and him together? Now there was some little green, sorry, I call it an AB this year. It's the green pen trick. Where you look at the first and look at the second, is anything shared? Like there is some stuff that will come out. And it gets down to this. Once we factor out all the shared stuff, the x squared plus 1 that's in both, etc., it gets down to this. But guys, do you think that, where is he? This and that are any simpler than that? Right? Okay, so then we went on. That's a good one. And they got frustrated when this one did. Then we did literally the max possible. Integration on crack. This should be possible. And it was. We could integrate it. We could integrate it. But check it. Right? Like you have an e to the and an ln. Like how do we integrate an e to the and an ln? And we ended up, we actually got some good stuff going. We got some good stuff going, but we were getting down to some nastiness. What ends up working? Not the hardest possible. Not the hardest possible. Yeah, so let's try it. Not the hardest possible. Ironically, it wasn't what u makes it simpler, and it wasn't the most possible that we could stuff into it. It was actually somewhere in between. If we do just what could naturally be integrated, not what could be nastily integrated with integration on crack, but what could naturally be integrated with, I don't know, whatever's left. What's left? X squared, e to the x squared. That's what's left. I mean, I have to have them all in there, incorporated. You guys, ready, set, go. You've learned from the people before you as to what best route to take. I want you to figure out how it works. Unless you have a photographic memory and you totally read that page in like 10 seconds. You still need to figure out how it works. So we've learned from those that have come before us that if you notice, this dv is not the hardest possible, let's do integration on crack to get our antiderivative. Oh, sorry, I kept on writing ors. My bad. You're going to have to use product rule for the derivative, yeah. There's a strategy when going from dv backwards, not necessarily the most that can be crammed in and forced in, that can be naturally. You see it? Yeah. But like our brains won't see that before, right? Not until we train it or not until we do a lot more practice. Riley, thanks for your question because it makes me be more careful too if I run out of room, not just to stop writing. Okay, I'm going to start playing just because I gave you guys a little bit of time. minus and negative is plus. You guys see it? That's nice. The other ones weren't going to work. This is going to maybe be one of those U sub things where you try different U's and you just keep on trying until something works. It's a little bit different application, but it's a very similar process in the sense of you're going to have to do some trial and error to get to you have a natural feeling, intuition, understanding of the direction to go. But as you noticed, none of our options for you were getting simpler when derived. Packing the dV as simpler when we or trying with squared and what he needs to have the du. Well, eventually we could get there. So then we're at the point where we have the integral of x e to the x squared. Psh, we got that. Because that's basically just what we did up above. Well, when we thought about his integral when we were going to almost use him and it didn't really work. Don't forget your plus c. Not 0 credit. Well, I think in a multiple choice, like you wouldn't choose the one without a plus c, right? You should be okay. But still, don't want to lose the silly points. Do you appreciate those who went before you? So that you didn't have to try all the other ways? But if it works, will it eventually become nice? Almost always. We have something called a loopy example. I know, it sounds very imprecise. And yet, it's the best way to talk about it. You guys got it? As a couple of people finish writing this down, don't worry, don't worry, don't worry. Ooh, look at my fun little font. Aww. He's up on the ceiling. Not literally. Loopy. 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 It's not near as much fun. He doesn't move with me. Party pooper. Get down this example. That's what I wanted. You guys pondering? Maggie, is this like 17? Maybe not. This might, I figured this would happen later in homework, but you said you got stuck on 17. Huh? It's one way. Are we ready? Loopy. To show me what you were able to get. No, what did I say yesterday? Submit how far you were able to get, right? Okay. No, you're okay. It was a valid question. Oh. Sorry, I just meant like attach it and then you have to turn in. That's all I meant. Sorry. Ready? I got the animation I wanted. Yeah. Aw, it doesn't work. He's not like pretty and in there. That's okay. Isn't he cute? So, what's going on? I'm trying to make it memorable. Is it working? Is it memorable? Okay. What's weird? Who's you? Let's do the e to the. Wait, the du is still an e to the. Huh. Let's make it a cosine. Wait, it's a sine. None of them? Everything? Always? Did he remember loopy? Cheater. Stop giving it away. Okay, so. Who do you want to make you? And these ones, to be honest, you get to choose. Who do you want to make you? No, well, you always have to choose. But here's the pause. Here's the pause. Here's the pause. Ready? Loopy has two different pieces that both loop. You don't want me to go off. Don't say no. Pause. Exactly. And that's what I mean by loopy. Because an exponential becomes an exponential becomes an exponential becomes an exponential. Cosine becomes sine becomes cosine. That's the point. Now pause. Some of you already figured it out. Awesome, good job. But the rest of the people are going to have a in just a second. So, Riley, you said you want the trig to be u, right? Okay. So cosine of 2x. The other guy, e to the 4x, is going to come right over here. I'm going to go ahead and do v equals 1/4. The point is the loopiness, and without the loopiness, we're in trouble. The point is the loopiness, and without the loopiness, we're in trouble. Focus. Okay, focus llama. Focus, I don't even know what. Okay, come back. Red panda? No, his ears are more cute. Anyway. Elementary teachers use the focus box. Yeah, it's a thing. It's a thing. Or they have like a little like ding, ding, ding. Or they have it can be a focused llama too. Anyway. Shh. Here we go. You guys do uv minus v du. But it doesn't work. Have some faith. It loops. Oh my goodness. We have some attitude today. But that's exactly right. Shh. But that's exactly where I wanted you to get, so thank you. Party poopers. You guys agree? Shh. Sometimes your logic or your intuition on a certain concept after having seen it for a day or maybe a day and a half is not complete. Hang in there. Sometimes we have a limited understanding and it takes time to have a fuller, fuller understanding. We have another integral though, right? We saw yesterday you can go twice. And I know some of you are like, it's not going to help. But I just said if it loops, it's a good thing. So don't change the orientation. Don't make the exponential u and the trigonometric dv. If you do, guess where you're going? Instead, keep going the direction you were going. So if you chose trig exponential, go again, trig exponential. If you chose exponential trig, go again, exponential trig. So u is going to equal the trig piece. dv is going to equal the exponential piece. Go again. He went over the 4. And then the negative with the minus became the plus. Yeah. Oh, yeah, they're right up here. You guys want them? Take one, pass around. Kathy, put it on the front table when we're done. If you have a Post-it from Wednesday, put it on. You'll get 2 next week. Are they coming? Focus. If you don't get here, you're not going to feel the full impact of exactly what's going on. Don't forget your plus 1/2 times all of this lucky 7. No, I don't want you. I accidentally hit the button. Now, if I was a mean teacher, and if this was a previous year where we were a little bit ahead instead of like a week behind, I would have you guys try this problem on your own and be like, it's totally possible. Just keep going. And a lot of you would have switched the orientation, and you would have gotten somewhere. And you would have gotten to basically 0 equals 0. Well, that sucks. I have no idea the answer. What's on the other side? This guy? Now hold on, pause. Those of you that already know that's cool, but the rest of them, this is the first time they've even thought about it. Be careful of your coefficients. Oh, be careful of your coefficients. Meaning, there's a 1/2 on the outside, and this 1/2 has to go into both. True? So technically, I am going to get 1/4 e to the 4x cosine of 2x plus 1/8. Double check my math along the way and make sure that I'm right. Sine of 2x e to the 4x. Now, it would be an integral that matches with this integral. What do I do whenever I have like terms? Combine them. So what do? I add this guy to that side, and I say, oh, plus. It was the problem. I brought it down. Crazy though, right? Because once we start with the problem, we kind of forget what was on the other side, but in this one, you can't forget what was on the other side. Because I need to add this guy to the other side, a 1/4, because it's 1/2 times 1/2. If I add them, I can combine them because they're like terms. And they don't equal 0. If they did, I'd be in some big trouble. Because then the integral goes away. But this integral doesn't go away. He's still here. It's just going to be 1 plus 1/4, or 4/4 plus 1/4, aka 5/4 times the integral of cosine 2x e to the 4x. Oh yeah, Riley, sorry. I rearranged it to make it match. I like to make it look nicer. I'm done. No, you're not. I don't want 5/4 of this guy. I just want this guy. So what do I do with my 5/4? I move my coefficient. The point of the loopiness is it looped back to what it originally was, but with a different coefficient. Whew, praise the Lord, because then I can move it to the other side, combine like terms. The integral is still there, and I have a coefficient to move to the other side. Now here's the dilemma. Exactly, Justin said it, plus c. And all this work, we kind of took the integral, the last one who we were supposed to solve, and put the plus c. He kind of got absorbed in this integral over here, so we would forget the plus c if we didn't remember the plus c. See? Okay, so we end up with, I believe, 1/5 e to the 4x cosine of 2x plus the 4 and the 8 becomes 1 and 2, and 2 and 5 becomes 1 and 10. Sure, why not? Sine of 2x e to the 4x. Good thing I have a smart board. Plus c. And I guess the AP, being who they are, might go ahead and pull out something like, I don't know, a 1/10. and an e to the 4x. Remember, they like to do weird things like that. And so this would be a 2 cosine 2x plus sine 2x plus c. Because remember, they like to take out the biggest fractions to make this 1/10, make that 2/10, and pull out the 1/10. Basically, you're integrating by parts to loop back around so that, as long as the coefficients are different, you can combine and then solve for the integral you originally wanted. Does that make sense? I think that's what you said, right? Who is this? Oh, there he is. Is it good if it loops? Yeah. It's keeping them straight, right? And the pluses and the minuses and the keeping it, yeah. As long as you get the idea of, oh, it's good to loop, it's good to loop. The only dilemma is if this was a 1, a plus 1, and that was a, anyway. If you moved and it became a 0, you only thought that was going to work. Either you made a mistake along the way, which usually isn't it. If you get a 0, there's usually a purpose. You might have switched the orientation, like started with trig as u and then went to exponential. That's going to make it cancel out. So you have 0 equals. You don't have the integral anymore, so you don't have an answer. That one sucks. Or there was a different way to do it and you didn't realize it. So it loops in a good way. What about this guy? Well, didn't you though? That's good and all, but hold on. Didn't you, though? Isn't it just going to take a while? Why? The x to the 4th, isn't it going to become an x cubed? Next time, isn't it going to become an x squared? Next time, isn't it going to be x? Next time, isn't it going to become a 1? Oh, there we go. The tabular method, though, is only really useful, I think, in one case. Now, what there is something called, okay. For those of you that don't share their humor, I think this is actually a sign of mutual friendship and respect. But I'm not entirely sure. Okay, coming back. I only like the tabular method when you have a higher degree polynomial. Because Liate, we do algebraic before trig. We do algebraic before exponential. Why? Well, because algebraic, eventually its power will go down. Hey, doesn't it? Do you remember L'Hopital's? Where you had like a 0 over 0 and you had to keep going, and we'll have to figure out how to show that work in a right way that the AP guys actually respect. Anyway, coming back. L'Hopital's. Remember if we had an x to the 100th over e to the x? What happens if you took the derivative? 100x to the 99. Still 0 over 0. I mean e to the x minus 1. Well, stink. Over, what would it be over that we have to keep going? It's an e to the x, but e to the x minus e to the x, that's just 0. Stink. Anyway, if you have a L'Hopital's where you have an x to the 100th and you basically get him down to show the bottom wins. Factorial, can't do an absolute value. Sorry, e to the x won't always be 0. Ooh, if you're going to infinity, there you go. If you're going to infinity, not to 0. So if you're going to infinity, then you plug in x to the 100th and then e to the, yeah, that works. Okay. Limit as x goes to infinity of x to the 100th over e to the x. Technically, bottom wins, 0. But would you show me that's true? Graph x to the L'Hopital's. Infinity over infinity. Keep going. It does get smaller, but not the coefficient, the power, right? derivatives. Same thing here, but this one you only have 4. You'll be fine. Let's do 4 integration by parts. I don't want to do that. Okay, tabular method. Tabular method says, let's make a column of u's and let's make a column of dv's. Because you would have to do multiple integration by parts to break the x to the 4th down to a cube, down to a square, down to a single, collecting the coefficients, as Justin said a second ago, along the way and not losing any minuses or multiplications, etc. Rough. So this is a little bit easier. Don't we know that the polynomial guy should be the u? He breaks down, right? Hopefully then we know that sine of 4x is going to be our dv. Just to make everyone happy. There you go. Pretend there's a dx next to everybody. That works. So, what do we do with u's in integration by parts? How do we progress with u's? What do we do? Du. How do we progress with these? This one, we take the derivative, right? On this one, we take the integral. Okay, so wouldn't the integral be negative? Now, when we have the du with the v, is this going to work? No. What would you have to do? I don't know. Go again. Eventually we'll get there. Aww. Because it's a positive, because we're going back to cosine, right? Positive? Why? Careful. Wait, I don't get it. How does it work? Well, we use the tabular method, as the standard deliver guy would say. Jaime Escalante, tick, tack, toe, oh. Ready? Stand and Deliver last year, the movie that we watched. So sad. Tic Tac Toe. Oh, you guys were gone when I introduced it. You were absent and you were in an ASB thingamabob. Anyway, last year. Yeah, when we were watching the movie, Pancho was up at the board and he was like, I can't do calculus. You want me to do it for you? Yes! The answer should be no. And he comes up, tic tac toe. Anyway, he's kind of mad. He has a heart attack soon now. That's a little bit after. Anyway, coming back. Down the stairs, and he's like, you all think he's dead. Okay, you remember that part. Tic-tac-toe. Why? This originally would have been your u, this originally would have been your dv, then we have our v, then we have our du. Wouldn't it be uv minus v du? Which integrated would have a new uv minus v du, which would have a new uv minus v du. Now, hold on careful. uv, he gets to be a positive. But the next time through, he's with a little negative integral, so he needs to flip signs. Then it's going to be back to the original sign. Then he's going to flip signs again, if he were to keep track of all of those minus the integrals along the way. So then I end up with a final answer of, hey, all the tic-tac-toe O's. Okay, with negative 1/4, x to the 4th, cosine of 4x. Minus, whatever the sign is, minus a negative, which will be plus 4 over 16 is 1/4, x cubed, sine of 4x. Plus, whatever the sign is, it's just a positive, 12 over 64, which ends up being 8, 4, 3 16ths. They want to check that fraction for me? X squared, cosine of 4x, minus 4 over 256. 6 goes in. Nope, it doesn't. 4 goes in. 64 times 6 over 64. No, we can go more than that. 3 over 32, yeah. Oh, I should have known that. Never mind. 256, it's like numbers of gigabytes, etc. Never mind. Doesn't matter. X. Wait, that's it? No, hold on. Couldn't we have integrated the 24 also? No. Couldn't we have integrated his u with the... Oh. We don't stop when we get to the constant, which we can integrate. We stop when we get to 0, which we're done. So there's technically one more. We would have needed to go to, and I know it's annoying because there's a 0 there, but remember, you pass over the next guy in the du progression. So technically there was one more, which would bring us to 1 over oh, 1024. I don't know why I'm not getting that. Negative cosine of 4x. It's been too long since there were flash drives of anything less than gigs. Anyway, there were like 2 megabytes, and then it kept on going, 256 and 512 and 1024. Anyway, we're not done yet. Shoop, shoop, last one. Shoop. Tic, tac, toe, oh. There we go. 24 divided by 1,000. It might go in evenly. Eight goes in. And 1, 2, 8, 3, and 128. Oh, there's a pattern here. Anyway. Plus. Minus. Just kidding. Plus a negative. Let's see. I know you don't like it, but guys, isn't it better than having to do 1, 2, 3, 4, 5 different integration by part lucky sevens? So much better. Yeah, go ahead. When's the tabular method useful? When you have a polynomial of something greater than x. I would include. I was going to say x or x squared, but I think tabular method will be nice. Tabular method will be nice when you have somebody that needs a few iterations to break down. Long story short. What if you were to do it with e to the x and sine of 4x? Loopy, right? Justin. Yeah. When you're doing your formula, your first set, u dv and du and d, you would have uv minus the integral of v du. And as you look at this guy, you would pick a new u with a new dv. Long story short, the first uv keeps the sign. So the positive is just keeping the sign. Everything after that is going to be off, as in the next uv is going to have that negative, opposite whatever it is. But the next uv is going to have the negative, so hence it's going to stay the same, and then it's going to be opposite. Then it's going to stay the same. Yeah. So think of the positive, negative as, and it has to be. Because look, the first term was not a positive, but it kept the sign. The next one flipped the sign, kept the sign, flipped the sign, kept the sign, etc. Tabular method. Not to be confused with integration tables, which there's a nice big old book of all these integration rules that applied mathematicians like to use. We don't want to see them or even memorize them, but in a college class they would probably give you a list of integration tables and say, here is a cool integral, and guess what? Someone at some point figured out the formula is this. Blah. So you guys, a little baby one, go. A little baby one. Why a table? Well, it's an x squared. It would need a couple times at least, right? We make it's a suggestion. It's not useless. You should in homework. You should a few times. Start with an ln. Start with an ln when you have it not with a polynomial. Oh, because you have to integrate ln. You should ln. Why? Could you memorize? Yeah, how do you integrate an integral? Double integrals? Yeah. Does it work? Does it work? Can't you just do 1 over x and then you end up with 1/3 x cubed? Could we go again? So just because you see this guy, does that necessarily mean that he is always the u? Maggie. Although they were going to see it in a second anyway. And a few people did try the ln and dv, and then you were like, well. Just because there's a little x squared doesn't always mean to use the tabular method. In this one, liate, you have to do ln first. But what do you get? Well, you get this guy, right? uv. Some people use the tabular method just to set it up every time, and I guess you totally could, because you have uv minus the integral of v du. They kind of do like an upside down 7. I don't know. I don't personally like it, but it's all right. So you could do the 1/3 and then x cubed over x, which would be x squared. To be honest, I would much rather use not the table. Not use the table in this example. But you could. But just to warn you, some college profs do actually have their kids organized, and then every time they're just taking out the uv and then like, hey, let's integrate this guy, then uv and integrate that guy, and I don't know. But this one, there wasn't really a repeated, because as soon as you do one iteration of integration by parts, you're good, because you can integrate that. It's going to end up being 1/9 x cubed plus c 1/3 x cubed ln of x. But come on, guys, be ready for those AP people. What are they going to pull out of that? Probably. A 1/9 x cubed. Why 1/9? Isn't that a 3/9? Pulling out the 1/9, when we end up with 3 ln of x minus 1. Oh my goodness, isn't that ln of x cubed? Oh, come on. I'm just preparing you. There wasn't really a point. Yeah, that was the point, is that you saw the x squared and some people, tabular, ln. Just because I teach you something new doesn't mean I want you to only use that from now on, though, right? So for the rest of you guys, technically, as soon as you saw the ln, you might have been totally fine, because this was good enough. Don't ask me, I don't know. So, what's a good summary? Well, if you see something with a polynomial, algebraic will always go before trig and exponential. So, Arian, maybe it's more moving in the table itself. Algebraic will always go before trigonometric exponential, because polynomial breaks down, trig and exponential will not. However, whenever you have a polynomial with inverse trig and logarithmic will always go before the polynomial, because we need to break them down first. And if we have something with exponential and trig, loopy. Question, does that address some of the stuff that you guys saw yesterday? Yeah. Coming next that we were supposed to introduce today? Wait a minute, where's my section and why is it missing? Anyway, there you go. Pert! It's not that bad. It's not that bad. I don't think there is one in the BC book. I think it's kind of just like you should know it. Anyway, we can see where we're going next. Growth and decay?
Wait, I'm still so confused. Like,
oh.
If you integrate a rate and then you integrate that, then what do you get? Like, if you integrate a rate and then you integrate that, what is that?
If you integrate miles per hour, you get miles. If you integrate miles, you get mile hours.
I don't know what that means, though. Like, mile hours? Like, what is a mile hour? I used to have those.
I like it. I like it in the context of an example problem we saw last year, which was the temperature outside. And if you integrate the temperature outside and then divide by the change in time, you figure out the average temperature. Not the average rate, but the average temperature. That one got my mind closest to what it is and what it does. If you integrate temperature, you're accumulating all the different possible temperature hours and dividing by hours and getting the average degree. Go research that if there's a name for it. No idea. Bye, guys. The goal. Have homework ready. Much better than it was last night to grade tomorrow. Tuesday.